Good morning, everybody, and welcome to Astronomy 100. Today is Tuesday, October 5th, and we have had just our midterm yesterday, and I'm glad most of you were able to complete it and do well in it. So we still have other assignments this week. We don't have any quizzes this week. We don't have any homework this week, but we have projects. We have two projects, actually. One of them was posted last week. I mean, it was announced last week. I went through it briefly last week, but it was not available until yesterday morning. And that has to do with the retrograde motion. So that's project one. The other project that you guys have seen also that was available yesterday, and that is a lunar observation project. So we're going to go through a little bit of overview of these two projects today. Also, this coming Thursday at 9 a.m., there will be a session dedicated just for these two projects, basically. It starts at 9 o'clock in the morning. It lasts at least for an hour, potentially for more. In other words, it depends on you guys if you would want to go longer. Where in the first hour, I'll go through both projects, explain the step-by-step basically process, what needs to be done to complete them, and answer the questions with you guys and show you how they are worked out, okay? It should be, for the vast majority of the time, enough for most of you. Now, some of you probably were into some difficulties after that. That does not, if you wish, replace or does not exclude you from asking more questions on this project. So on the road to make sure that you are doing them right, okay? So this is the idea behind them. This is not it though. There will be a third project, most likely it's going to be posted early next week. And that would be it then. So that will be the three projects that are going to be assigned to this class. Two of them you must submit. One of those two required project that you must submit is the lunar observation project. That is not avoidable. That you cannot avoid. You have to do the lunar project. If you don't do it, it's going to affect your grade. So that you must do. Then the other two projects, you have the option to do one or the other. So basically, you will have three projects. One of them is mandatory, and two of them you choose one or the other. Or if you wish, you do all three of them, in which case Canvas will automatically include your lunar project as part of your grade, but chooses the highest of the two of the others that you submit. So that is basically the plan, okay? The third project is not going to be dealing with the solar system because the first two are dealing with the solar system, namely the lunar observation has to do with the moon and observing it actually outside. So this is something that you have to do outside of your home, outside of your room. It has to be in the open. So you go outside and you look at the moon and you report your observation, okay? So that's one thing. The other project is the retrograde motion that deals mainly with the planets and one dwarf planet in the solar system. It deals with Mercury, it deals with Venus, it deals with Mars, it deals with Jupiter, it deals with Neptune. And in addition to that, it deals with the dwarf planet series, okay? Those are planetary objects, I mean, parts of the solar system objects, okay? So it's still solar system. Obviously, for this project, you don't need to go outside. All you can do is sit at home or your room, wherever you are, or your office if you are at work, and then pull a piece of paper and start basically drawing. And I'm going to explain what you need to draw. Pick up a ruler also and draw, and I'm going to explain what that part is. Pick up a calculator, basic calculator, no square root, no cubic root, no nothing, okay? Just basically multiplication and division. Once you do that, you need to add numbers, okay? Once you do that, you make predictions. So that is what the retrograde motion. So all of this too have to deal with the solar system. The third project deals with the stars outside of the solar system, okay? Because we did not really redo the stars yet, so that's why it's kind of delayed a little bit, and the due date will be due after the topic is covered. So that's basically the 3 projects that you're going to be dealing with. And that concludes everything in terms of assignments or kinds of assignments that you could have in this class, because we've seen participation quizzes, we've seen participation discussion items, we have seen basically all kinds of ways of getting involved in the class and getting a grade for it. We have seen also homework type questions, which you will have also down the road. We have seen also midterms. There was already one that was completed yesterday. And now you're going to be exposed to the last type of assessment in this class, where you're going to do actually writing. You're going to actually write stuff. And I'm going to explain also how we write things in science in general, how we communicate our ideas, which is a critical aspect of science. As a scientist, yes, you're going to go and learn about the topic, conduct observations, and then communicate those observations. So it's critical part of the process to be able to communicate clearly without ambiguity about what you know. So that is really the part of the assessment, which has to do with the projects. Okay, so this is basically the whole perspective of the class. So let me delve into the screen. Let me share the screen with you guys and show you what I'm talking about. Share. Okay, so the retrograde motion of Mars was from last week. And then we have the new project, which is the lunar observation. Last week, I don't know if you guys remember or not, I know we had the excitement of the midterm, some of you probably forgot, and that's why I did not really, I made it just a brief intro there, is that when we clicked on it, we only saw the rubric, which is an essential element of doing projects. When you're doing project, it is a good idea to always refer to the rubric, okay? Refer to the rubric, okay? Because that's how you're going to be assessed. And that serves as a blueprint, if you wish, or framework for your reporting, so that you know exactly what to report. But last week, we were not able to see this, at least when I clicked as a student. I really had to click as an instructor to be able to see the instructions in here. The instructions, as you can clearly see, is not much, at least according to this thing in here for the project. There are 2 links in here of importance. One of them has the option that you may not do it. Okay, so it's up to you really, honestly, on how your style is. However, whatever your style, this must be included. This is the rubric. So if you choose to do the PDF, which serves as a guideline, this are included there. If you choose to do another way of reporting, that's fine, as long as you follow the rubric in this order. So do not start with the conclusion, for example, or start with table 3. Okay, you start with the objective and you move down. Okay, when you're doing other than the PDF, if you choose to do something else. Okay, if you click the PDF, it has the same instructions as this link. This is really where everything is happening in terms of this project. So when you click on the link, it takes you to the instructions for the lab. Obviously, I cannot really fill, because this is actually a browser on Canvas. So there is no place for me to fill information in here or to do things with me in here. So if I want to do this, either I print this or I print the PDF, one of the 2. Or use the PDF electronically if I want to, okay? Because at some point I have this table in here that has records from July 10th of the year 2005 and extends 10 days later, another observation, and 10 days roughly later from the 20th of July to August 1st, and then August 10th, August 20th, September 1st, and then on these dates, November 10th, And then I move from November 10th to November 20th, December 1st, all the way till March of next year, 2006. This data was reported to you. Somebody went and looked at the moon and did this reporting. So what they reported for you are two values. They reported the right ascension, which is really a position with respect to the clock, if you wish, where 360 degrees, the full circle is 24 hours. Okay, they use hours instead of degrees. That's really for the right ascension. So think of a circle instead of 360 degrees, 24 hours, where hour 0 is in the east, and then you go to slightly south, and that's hour 1, and then you continue just like the clock moves. Okay, so that is the right ascension. So 1 hour and 13 minutes, 1 hour and 37 minutes, and so on. The next day it was 2 hours and 4 minutes, and so on and so forth. The degrees, which is the inclination, the declination in this case is actually in degrees. The declination is from the horizon up to the zenith above your head, which is in degrees in this case. Okay, so again, forget about what those mean. Look at this: is hour 1, hour 2, hour 3, hour 4, hour 5. On July 10th of the year 2005, where was Mars was? Mars was at the position 1 hour and 13 minutes and 4 degrees and 54 seconds. Okay, 1 hour and 13 minutes. This is 1 hour. This is 2 hours. These divisions are 1, 2, 3, 4, 5, 6. That means that 60 minutes, each one of them is 10 minutes. So this is 1 hour and 10 minutes. This is 1 hour and 20 minutes, but it was not in 1 hour and 20 minutes. It was 1 hour and 13 minutes. So right below halfway. Halfway is 1 hour and 15 minutes. Slightly below it is 1 hour and 13 minutes. So I draw with a ruler a whole line stretching up. That is with a pencil, of course. I'm not going to draw this with a pen, because if I draw it with a pen, this whole thing would become a mess, so that I can erase this. So 1 hour and 13 minutes is here. But wait a minute. I need to find the 4 degrees and 54 seconds, okay? 4 degrees, this is 0 degrees, this is 5 degrees. But I don't have 5 degrees, I have 4 degrees and 54 seconds. 44 minutes, I'm sorry. So I have 0, 5, 4 is here, and 54 is roughly somewhere in here, okay? So this would be the position. If I draw a line, the two lines meet somewhere in here. So I draw a dot in here. That's where Mars was on that date, which was July 10th of the year 2005. Okay? These dots that you see in here, those are the background stars. So I continue. So that's July. I do the same thing. 1 hour and 37 minutes, 7 degrees and 9 minutes. So 1 hour and 37 minutes, 1 hour and 20, 1 hour and 30, 1 hour and 37 is somewhere in here. So I draw a line in here and then find the 7 degrees, and 7 degrees is going to be here. This is 6, 7. So 7 degrees and 9 minutes, so somewhere in here. So Mars was here on July 20th, 2005. Remember, it was here somewhere, and now it moved in here, and so on and so forth. So I draw these lines, as you can clearly see, and follow the position. And at some point, it's going to move backward, and then it's going to move forward. Then you connect the lines. That is the path of Mars. Okay? Again, we're going to meet on Thursday. We're going to draw these things together. Okay? Then I answer a bunch of questions, which we're going to discuss on Thursday. Then I draw this one. I know I talked about this one last week more in detail. This is the geocentric model, where the Earth is the center of the solar system. I draw a line from the Earth to position 1. I draw a line from the Earth to position 2. I draw a line from Earth to position 3 and project it on the screen. This is the background stars. The stars in the that don't move, okay? And then from Earth to position 4, Earth to position 5, Earth to position 6. And then I see that according to this thing, If I label 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then I see that this thing is moving back and then moving forward. I do the same thing where the sun is the center of the solar system, heliocentric model. I draw from 1 to 1 now and project it in here. From 2 to 2, I project it in here. From 3 to 3, because I'm still on the Earth, I'm not on the sun, to draw a line from the sun, I still draw it from the Earth to 3 to 3, 4 to 4, 5 to 5, 6 to 6, 7 to 7, 8 to 8, and 9 to 9. And then I'll also label this 1, 2, 3, 4 all the way to 9. And then I see the retrograde motion of Mars. The last part of the project is to do these calculations. We're given the period of the Earth, which is 12. We're given the period of this object, which changes from 1 to 1. And then you find this S, you put it in here, and you do simple addition of this to that, and you're going to tell me when it's going to happen next. That's the whole project. Does not sound difficult. I mean, it's long. That is really the key thing in here. So the difficulty of this project is its length. So do not leave it. This one is due October 23rd, by the way, this month. So do not leave it to October 23rd and start working on it. That is a big no-no. If you do it that way, you really are cutting it too short, okay? That is not good. And taking a big chance with the STAR project that may be too intense, and this one probably is going to be a better alternative for you. So do not leave it until then. I would suggest you start on it ASAP, especially this week, since we're done with the midterm and we don't have any other assignments. This is probably a good thing to start right away. Okay, so let me go back home to talk about the other project, which is the lunar project. The lunar project had all of these things that I must read, and then I start answering question 1 and 2, and then I have to go outside. On October 13th, which is not this Wednesday, not tomorrow, a week from tomorrow, the 13th, okay? I have to look at the moon, see how it looks like. I have to be on a specific time, though. Try to restrict yourself to that time. You don't have to, but try to, if you say 9 p.m., which is a good time, stick to 9 p.m. If it's 9:05, just put in here 9:05. If it's 9:06, put 9:06 when you looked at it, okay? You need to report the time. You tell me the shape of the moon, how it looks like, and you're actually going to draw it in your report, and then you're going to name the phase and the position of the moon. Was it in the east toward the horizon? Was it the east toward mid quarter of the sky? Was it above you? Was it in the west? Was it all the way to the horizon, or was it not there at all? Okay. And the shape, was it full moon? Was it quarter moon? Was it half moon? Was it, what are we looking at in here? Was it a crescent? Was it crescent pointing to the east or crescent pointing to the west? Or was it, so you're going to tell me, is it going to be, maybe the moon is actually on toward a little bit above the horizon, but toward the south or the north, depending on where you are and how you're looking at it, okay? You're going to track it on that night, draw it, and then a week after the 13th, which is the 20th, which is the other Wednesday, you're going to go outside and do the same thing. The 27th, you're going to do the same thing. The 4th of November is the last day when you're going to do the same thing. All of them occur on Wednesday. Now, if the weatherman tells you that the Wednesday is going to be cloudy, check the Tuesday. If Tuesday is good, then go for Tuesday. If Tuesday also is not good, then go for Thursday. If you cannot do it in any of these days, basically you're going to report the fact that the weatherman told you not to go because the clouds were too much, okay? You cannot see the moon on those days. Try nonetheless to go. You might be surprised that there will be an opening in the sky, okay? So in other words, the 13th is written in stone. Very rarely that you could really do the 12th or the 14th, okay? Stick to those dates. This project is mandatory, it's not an option. You have to go outside and look at the moon and report its position, shape, and draw the shapes and all of that. Okay. To help you with, again, there is a rubric in here to help you, and rubric is very important always, okay? To help you with the, man, I should not have done that. I opened, okay, it opened, good. So this is a Word file. It's a good idea to download the Word file. Actually, you have to download it if you're going to. Let me download it because there is a trick with it that I really need to explain in here. So I'm going to download, and once it downloads, I'm going to let me open it with Word. Once it does, I'm going to share with you the Word file. Share the Word file. Let me tell you what that and you probably have seen this in the past, okay? Once you open a Word document that like this one, I said open with Word, it gives me this thing in here, enable editing. Please choose enable editing if you're going to use this file because it helps you in your reporting. So what I'm going to do is I'm going to enable editing. I clicked on it, didn't do anything, so I have to click again on it. I need to put my name. If I want to put my name, I really have to double click on this side. Now I'm going to write my name in here. Then after that, once this is the header, once I'm done with the header, then I'm going to go down and start answering the questions. Okay. One of the questions you must read these things, and again, we're going to meet on Thursday to discuss these things, is we're going to answer this question related to this drawing. You have the moon, you have the sun, you have the moon, and you have the earth, and it's related to positions A and E, A through E, okay? And then you're going to, based on that answer, you're going to draw pictures of how the moon looked like. And then now this is the actual observations. This is the key in here. So when you go outside, you're going to report the information here. The position is not necessarily accurate. Please do not report angles and hours and things like that, because all I need really is approximate position in the skies. North, northwest, south, west, whatever you have in the south, southwest, whatever you think the position is with respect to you. And then you're going to draw in here. If you're, this cannot be a picture that you paste in there from Google or somewhere else. This must be something that you actually hand drawn yourself with hand, with a pen or a pencil, and or with paint, something that you did actually yourself, whether electronically or on piece of paper. And then you can take the image and upload the image of your own drawing. Do not include a link from somebody else's work. So this has to be you, okay? Based on your observations, based on where you are, okay? The same thing for this part, the same thing for this part, and the same thing for that part, okay? So, and then you're going to draw conclusions. Okay, based on what the objective was, what you did, and the observations, and so on and so forth. If you're into some difficulties, you're going to report them in there. So let me stop sharing and let me go back into the where I was here. Let me click out. Let me share now the screen. Okay, again, we're meeting this Thursday to go more in depth about this project and how we're going to handle them. One of the things that you really need to know is how to write your report. So how we're going to put the tense that you need to use in there and the way that you express yourself. So that's the whole thing in here. So I'm going to ask you guys either to attend live the session on Thursday. The invitations, you will not receive them until Thursday morning at 8 a.m. 8 a.m. If you don't receive an invitation from me, there is something wrong with your the notifications of your Canvas, because it's already pre-programmed so that you receive the invitation at 8 o'clock in the morning. I don't want you to receive it to be sent earlier, because what happened is you'll receive a bunch of other messages from different places, and then by the time comes 9 o'clock in the morning on Thursday, it's going to be buried down in the messaging system, and you probably start having difficulty finding it. So Thursday at 8 o'clock, you'll receive the invitation. And then at 9 o'clock, we're going to meet. Please attend live so that if you have any questions, to make it more interesting and to answer all of your questions. And if you cannot, you must watch the recording, okay, to help you with the projects and how to do them, okay? So this is the item of the discussion today, is attend live or recorded session on projects this Thursday. That's how I put it, okay? You can put it in your own words. It doesn't matter. The point being in here is that you need to remember that this is the last type of ways of being assessed, and you really need to master it to maintain that A level, basically participation and engagement in this class, to maintain the grade and make sure you do everything you're supposed to do. Sounds good?
Yes.
Okay, very good. Thank you. Okay, so very good. So let me continue with the class. Let's go down in here. We came accustomed to these things, as I was saying in the beginning. There was no quiz, no homework this week, other than basically we just completed, like I said, the exam. We still have projects, and hopefully we complete those, and we will start our regular stuff next week, where we'll get also quizzes and homework and other things. Okay. We have the week before review, and then we have the discussion that is going to be posted in this session here. And then we have this unit. So let me briefly talk about this unit. Okay, no, that's not it, is it? No. Let's go back into the objectives. I'm sorry, I'm kind of lost in here. I mean, I leave it to you. This is actually the PowerPoints that you guys are supposed to have, which is in here. And also, what was I going to say? Do not forget that you're supposed to do the reading of that unit, unit 41. So let me go back into the objectives to see exactly what we have this week. Again, the first part of the objective is what I just talked about in terms of the projects. So you have so far 2 projects. There will be a third one, and that would be it. Okay, that will be all she wrote in terms of assignments. Okay, this week's topic is on Venus. Let me put it in context so that we see where we stand in terms of where the big picture is. So far, we learned about Earth as a planet. Earth, as it turns out, is an interesting planet for several reasons. The biggest reason, of course, is that it's within our grasp. We can do measurements on it, we can do observations on it, we can basically study it thoroughly. And we know a lot about the Earth. We don't know everything, but we know a lot about the Earth in terms of its structure, in terms of a lot of things, in terms of its composition, in terms of a lot of things. We took that model and projected it on other objects in the solar system. It turns out that the Earth shares a lot of similarity with at least the inner planets in terms of structure. If we look at Mars, for example, terrestrial object. If we look at Venus, which is another terrestrial object, if we look at Mercury, which is another terrestrial planet, and the Moon also, which is another terrestrial object, all of them share more or less similar compositions, okay, with fluctuations here and there, depending. In terms of the atmosphere, it turns out the Earth can teach us something about the outer planets, since they are mainly gas. And we saw also some of the forces that govern the weather and the climate and its surface. So we learned something, and we're going to try to extrapolate that information to apply it to other objects in the solar system. So that's really the whole idea behind it. In terms of proximity, of course, we immediately jumped after that to the Moon, and the Moon also is within our grasp because we also went there. We collected rocks from it, we observed it, we did measurements on it. We still don't know a lot about it, but we know enough to basically describe its surface and probably even its structure to some extent, and a lot of information about the Moon. Not only that, but we saw how it was formed. Actually, we came up with a theory, and that theory so far holds water in the sense that it is matches observations and data so far collected and how it came out to be. So we have at this point where we stand. That's where we stand. Then the closest object to the Earth, other than the Moon, of course, is Venus. In terms of proximity, Venus, I mean, side by side, of course, because these objects, they move around the sun, and sometimes they will be on the other side of the sun, and we cannot really make that comparison. The thing with it side by side, After the moon, of course, is Venus. Venus is the closest object to the Earth after the moon. That's not it, though. There is far more to it than this. Venus, in terms of size, is very close from the Earth. Very close, very slightly smaller. But other than that, it's similar to the Earth in terms of physical size. And also in terms of mass, it's similar to the Earth. So it's not that far from the Earth, very close from the Earth. As a matter of fact, in terms of gravity, if we were to stand on Venus, which we cannot, and I will tell you why, okay? We would weigh the same for all practical purposes because the force of gravity is almost the same thing. So for all practical purposes, the two planets are identical. That's why they were called twins, or the twin planet to Earth is Venus. However, there are differences. One of them is the atmosphere. The atmosphere on Venus is super charged, super thick. I don't mean charged electricity. I mean, it has a lot of stuff in it compared to that of the Earth. As a matter of fact, on the surface of Venus, the gas there, which is the air, the atmosphere, does not behave like an air does. It behaves more like a liquid because it's so dense, okay? It behaves like an ocean, really. So that is really the biggest difference between them. That is one thing. The other difference is the composition of the atmosphere. The composition of the atmosphere on Earth is mainly nitrogen with some oxygen, and on Venus, it's mainly carbon dioxide with some other traces of other elements like nitrogen and other elements, especially sulfuric acid. So it's really acidic atmosphere. So it's really not suitable for life as we know it. So that is really the biggest difference between them, which led to another problem on that planet, and that is the temperature and the pressure. Those two numbers are much higher than on Earth, for example, okay? Extremely high pressures, extremely high temperatures. As a matter of fact, the temperature on the surface reaches about 870 Kelvin, which melts lead. No electronics could survive for that long. As a matter of fact, the Russian landers there survived only for probably an hour or so on the planet because it's so hot. The other thing is the pressure also. The pressure is very high. It's about 92 times more pressure on that planet than it is on the Earth. So this is really a different conditions, if you wish, in terms of the difference between the two planets. So one of the questions that we want to understand is how come? Why Venus, albeit it's similar in every other aspect to Earth, has gotten in the way it was? One, at least some of the work that was published recently suggested that the planet was actually similar to Earth in all of the other aspects. Namely, it had oceans on its surface, water as we know it, liquid water, potentially also water in the caps that also was in this solid state, namely ice too. And then albeit the oceans there, they were not as deep as those of the Earth, but they were shallow waters. Still, there is water. Of course, the atmosphere had water in it too, in the form of vapor, but that's basically the three phases of water existed on the planet. For some reason, studies indicate between 150 million years ago or 450 million years ago, something switched on the planet, so that more and more volcanoes erupted in the same time in different points of the planet. That activity, that outgassing activity, released a lot of carbon dioxide in the atmosphere, which trapped more heat as it came in the form of different radiation frequencies from the sun, absorbed by the surface, and then re-emitted back in the form of infrared radiation. That infrared radiation does not penetrate the carbon dioxide basically loaded air, which actually transmits it back to the surface, increasing the temperature even further and causing evaporation of the oceans. As water is actually evaporates, it acts also similar to what carbon dioxide does. So it's really a greenhouse gas too, in a sense that it also absorbs infrared radiation, transmits it back too. So that causes the temperature to increase even further, which caused more water to evaporate and accelerate the process. So the process really started slowly, probably, and then accelerated to an incredible number that it evaporated all the oceans. The temperature gets so high that the water molecules, for the most part, dissociated and broken down into oxygen and hydrogen. The hydrogen, being now at higher temperatures, gained a lot of kinetic energy. All of the atmosphere, as a matter of fact, there is very, very active. Because of the high temperatures. So the problem with the hydrogen is super light compared to all of the other elements. So it basically rose higher and higher in the atmosphere. And then because of its light properties and extreme high kinetic energy, extreme velocities, basically, it escaped the planet. Now the planet has reached the non-return point. It's not going to be able to go and recover from it and become back the way that it was in the past. The problem with it right now, it's reached equilibrium. It's not like a process where it's accelerating anymore. It's done. It's done for. Because as the radiation comes from the sun and try to penetrate that thick atmosphere, it gets reflected. As a matter of fact, the planet has a very high reflection coefficient in a sense that it looks bright from outside. As a matter of fact, other than the moon, it's the second brightest object in the sky. And people, when they were looking at it, they immediately see it after the sun goes down, and they called it the evening star. And just before the sun came up, it's bright in the sky too, and they called it the morning star. Initially, it was thought two objects, and then at the end, we realized it's the same one. It's a super bright star. And of course, it's a planet now, we know. The reason why MS stars are actually, that's how they were called, actually, wandering stars, the planets. So that's really the properties of this planet from the outside. So it really, really has that effect. Now, this teaches us something very, very important. Whatever happened to Venus could happen to the Earth. In a sense, the Earth could go through a similar process and basically be done for completely and in a non-reversible fashion. That's it. So that is a very, very important thing in here that we really need to understand what has caused that planet to go through that process. Was it internal properties out of the control of anything? Was it this volcanoes triggered by some sort of a, probably initially at least, some sort of an asteroid that hit the planet or something, that specific angle that caused initial volcanoes, and that those volcanoes caused more and more volcanoes somewhere else. So I don't know. There are all kinds of studies at this point that are competing, and research on it is ongoing, trying to understand what caused the process to begin with. Initially, when the planet was basically analyzed and thought of, they thought that, hey, it should be similar to the Earth, so liquid water must exist in oceans in there, it's being young. So people thought, these sci-fi people thought that it was habitable, in a sense that there are living organisms in there, plants and all, including dinosaurs, and everybody started writing all kinds of things about it. But we know today that it's far from the truth. As a matter of fact, the picture you see in here is from the surface that is baked under high temperatures and being basically rained on all the time by acid rain. So this is really not a very hospitable place for any kind of life that we know, at least. Okay, so this is how the planet looked like on its surface. One of the key differences between it and the Earth, first of all, in terms of the topology, it doesn't look too different. I mean, the colors in here may be suggesting oceans, but there are no oceans on the planet, okay? The colors in here are just for the lowlands and the highlands that extend anywhere between a positive 8 kilometers from the highlands to a negative 8 kilometers to the lowlands, okay? So this is basically how the planet looked like. All of these names that you see in here, they're actually after famous women, whether in history or from mythology, with the exception of this highland in here, Maxwell Mountains. So other than that, all of these things is basically related to how that's how they are named. And again, the topology doesn't look too different. One of the key differences between it and the Earth is at least when we look at the structure, again, we need more information on this. Honestly, we need more observations on it. And there are all kinds of projects that are planned for it, on at least because of the high density atmosphere, that we're planning some missions in the atmosphere, and then probably we're going to send probes to the surface and collect data on it. Is the structure. We know that it has a crust, but the key difference between its crust and the crust of the Earth is that it's only one basically block of crust for the most part. Whereas the Earth is made out of plates, and these plates are up against one another on the Earth. And what they do is, when they go under one another, they take with them the constitutes what basically carbon itself, and recycle the carbon and basically take it back to the surface and underneath the surface. So this is a process for the Earth to get rid of that excess carbon. Albeit it's extremely slow, and the way that we're going at this point with the release on more and more carbon, where basically the balance is offset in the sense that we're going through a greenhouse effect ourselves. On that planet, there is nothing in that sort. So the carbon that is released stays in the atmosphere. So that is one key difference between them. There is a mantle, just like of the Earth. Again, this is based on models that we have in here that can explain a lot of things about it. And there is also a core. And in the core, of course, you have the molten part of the core. The reason why it must exist there because of the similar amount of matter that it has like the Earth. So there must be heat, and that's expressed in terms of how the planet tries to get rid of its heat using the volcanoes. That's one way of basically disposing of that excess heat. So again, there is a molten part of the inner core that is mainly iron and nickel, and those are two metals with a lot of electrons available for them to cause electricity. Now, what we observe is the planet does not have a magnetic field. Why is that? Well, it has to do with the motion. The planet spins around, it's around the sun first. It goes around the sun. That's a year on Venus. But it also spins around its own axis. Look at the way it is. It's going counterclockwise like everybody else around the sun, but on its axis is going clockwise like the clock does. So as it's moving counterclockwise, it's spinning counterclockwise, spinning clockwise, and in doing so it's spinning like this, but actually going like this. I'm sorry, I probably put the picture. So it's going around the counterclockwise, but it's spinning with the clock. You know how the clock goes from noon to 1 o'clock and 2 o'clock and so on and so forth. And it's extremely slow. That's the whole thing with it. It takes about 243 days to go 1 day on Venus. Extremely slow motion. So the fact that you have a molten part of the core, which is the outer core, it's melted, does not help much because of the fact that the slow motion. So that does not produce enough current to produce a magnetic field. That's why we couldn't detect it. So the models fit beautifully at this point, and everything indicate that the models are correct in terms of things based on the rotation piece of the planet. A key question that needs to be answered is, because if it happened to the Earth, it's going to be devastating because of the because the planet really does not really need protection from the UV radiation, because that does not penetrate because of the super thick atmosphere. But the Earth needs a magnetic field to protect it from not just from the fast moving particles that hit the atmosphere. They're charged particles. So the Earth needs the magnetic field to protect life as we know it. So what causes the planet to slow down so that they take that long? Again, is it the friction with the atmosphere that slows it to the point that it's basically spinning so slow backward? Is it because of the thick atmosphere again? And this process, if it started a long time ago, so probably is going to continue further, okay? Is it a collision with an outside object that causes this one? Again, there are all kinds of studies at this point and people trying to understand what happened to Mars, because it can help us also here on Earth. And there is another aspect that it can help us with. In our search for exoplanets, planets outside of the solar system, we have a region around the planet, around the star, basically, where we think water can exist in the three forms: ice, liquid, and gas, okay, vapor basically. So these three phases of water are critical for life as we know it on Earth. We need oceans, we need ice as part of the process that developed, go through it, and also we need the vapor in the atmosphere that is part of the process that we have on Earth. So that's really where life is. Here is the problem. On our case, our solar system, we have three planets that evolve in that region, which is called the Goldilocks zone on the stars. And each one of these three planets evolved in a different fashion. One of them is so hot that the water does not exist in liquid form. One of them is too cold that the water basically boils even at those low temperatures because of the lack of pressure, namely Mars. One of them, the Earth, which is really has everything at least for it going so that it exists on one of the three phases. When we look at stars outside, trying to hunt for planets to see if they have they are potentially basically habitable and they have life on them, what are we facing at? Are we looking at something like the Earth really, or are we looking at something like Venus, or are we looking at something like Mars? That is really part of the things that we really have to understand in our hunt in there and try to project what we know about at least this planet here on the from the solar system into objects of our outside of the solar system. Again, it's really a fascinating thing in here, Venus is, and we are still learning a lot about it. I know there is a lot of effort dedicated to Mars because it's actually approachable. Mars is because you can put a lander in there, and the picture that you see behind you, at least prediction, is from the last mission that we sent on February 18th, the Perseverance lander. But Venus is a big challenge. It's a much, much bigger challenge. Yet probably it can teach us more about the Earth than Mars does. Okay. So this is really the unit for this week. I know this does not substitute for what you guys are supposed to do from this unit, which you're supposed to go through. Here is a PowerPoint for you guys. Also, you have the book. And starting from next week, of course, we will have assignments related to questions and quizzes and also homework assignments, because we want to resume normal things because they really work. They help you really retain more of the things that we discuss. And of course, you're supposed to go through the 10 pages or the 8 pages of this unit so that you know what's going on. So this is everything for this week. Do not forget the assignment this week, which has to do with the projects, and that we're meeting this Thursday to have a more in-depth look at these projects and how to do them. I know I basically talked a little bit about them, and for some of you probably is enough, but I still urge you and strongly urge you either to attend live with us on Thursday at 9 o'clock. And that is really the ideal thing, because then you can ask questions and make this thing more interesting. Because something might be obvious to me, but for one of you or two of you, that might not be so obvious. And that person, if he or she asks that question, usually others will be very grateful because probably I did not make it clear, or I did not think that it was that clear or something like that. So we have to make it to enrich it by you guys attending live. So this is the preferred way. If not, then you're going to watch it recorded. I planned it for at least minimum 1 hour and potentially for 2, but experience had shown that when something goes for more than an hour, it starts to lose its effect. In a sense, it becomes too much and then probably cumbersome and becomes in the way, and it's not going to be really great unless we change the topic and walk away and basically go and grab something and then come back, which probably could do on that day too. We don't want to continue for 2 hours, but at least plan for a minimum of 1 hour. And if you choose to leave after that, there is no problem, you can leave, okay? So we should really cover enough stuff for 1 hour to get you going with them. Sounds good? Okay, no problem. Okay, so I'm gonna stop the recording right now. And hopefully I will see you on Thursday.